Hello students, you must have understood first chapter. In the first chapter, I had given several questions. You must have tried those questions. If you have got any sort of doubt, you may send your doubt to the mail ID mentioned here. Either you can click an image or you can scan it, send a PDF file. We will begin with the second unit, algebra. In this unit, we have two chapters, polynomials and linear equation in two variables. We have already studied the concept of polynomials and developed notion of working with polynomials in class 9th. The study of polynomials is of utmost importance in algebra and so in mathematics. The study of quadratic polynomial especially has wide-ranging applications in business, life sciences and economics, where several problems can be expressed in terms of quadratic polynomials. In this chapter, we shall study about zeros of a polynomial in more detail with particular reference to quadratic and cubic polynomial. Also, we shall study a famous result known as division algorithm for polynomials and simple problems based on it. Before we actually begin the chapter polynomials, let us review some of the basic concepts which we had studied in our previous classes, that is from class 7th onwards. In class 7th and 8th, we add a very important concept called as algebraic expression. This is the base for understanding polynomials. Algebraic expression is combination of numerals, literals and arithmetic operations. Numerals are nothing but constants and coefficients. Literals are variables. They are nothing but the alphabets used for representing a particular thing, unknown. Algebraic expression also contain arithmetic operations. They are nothing but addition, subtraction, multiplication and division. Suppose if I consider an algebraic expression x square minus 2xy plus 3 by 4y minus root 2x plus 7. In this particular algebraic expression, there are numerals, literals and arithmetic operations. Let us understand. Look at it properly. Observe this algebraic expression. X square 2xy 3 by 4y root 2x 7. These are terms. These terms are separated by means of these symbols. These symbols are nothing but addition and subtraction. Not only that, you observe x square is same as 1 multiplied to x square. In this term we have minus 2. In this term we have plus 3 by 4. In this term we have minus root 2. In this term we have 7. These are numerals. In particular, constants. There is only one constant in this algebraic expression, that's 7. 1 minus 2 plus 3 by 4 minus root 2. These are coefficients. 1 is a coefficient of x square, minus 2 is a coefficient of xy, plus 3 by 4 is a coefficient of y, minus root 2 is a coefficient of x. In this particular algebraic expression, there is x as well as y. So this is an algebraic expression in 2 variables. There is no restriction on how many variables it should have. It can have so many variables. Let us take some more algebraic expressions. I am taking few. I have taken 5 algebraic expressions here. Are they polynomials? Can I say that the algebraic expressions which are mentioned here as a polynomial? It's a very important concept. Listen carefully. We have to look at each variable and power of the variable. If the power of the variable is non-negative integer, the power of the variable is non-negative integer, same as whole number. Non-negative integers refers to 0, 1, 2 and so on. They are whole numbers. If the power of a variable is a whole number, then we say that algebraic expression as polynomial. Look at the first example here. This example. Can I say x square plus 1 as a polynomial? Yes, it is a polynomial. The reason is there is only one variable and the power of the variable is positive number, and clearly the power is a whole number, so it is polynomial. Look at the second example. Root 5 x square minus 3 z to the power minus 5 y square plus x to the power 4 minus 3 y to the power 5 by 7. Observe it carefully. In this particular example, we have got 3 variables x, y and z. Now we have to see the power of these variables. Look at the second term. Power of the variable z is minus 5. And also look at The fourth term, power of the variable is 5 by 7. This minus 5 and 5 by 7, they are not whole numbers. It's a negative number and a fraction. So whenever in an algebraic expression, if the power of the variable is not a whole number, we say that it is not a polynomial. Look at this example, 5 by x cube plus 3x square minus 6. Can I say this as a polynomial? No, it is not a polynomial. What is the reason? You have power here 3, you have the power here 2. Is it not a polynomial? No, it is not a polynomial. The reason is 5 by x cube is same as 5 multiplied to x raised to the power minus 3. We had this in exponent chapter that any number, say a to the power minus m, is written as 1 by a to the power m. So there is a negative power here. Since the power of the variable is a negative, we say that it is not a polynomial. Same is the case with this example, y plus 1 by y. This 1 by y is same as y raised to the power minus 1. Since the power is not a whole number, this particular example is also not a polynomial. Look at the last example here. 3t minus 2 divided by t square minus 2x plus 5. In the numerator, we have got the degree of the expression as 1, and in the denominator, the degree is 2. It cannot be further simplified since the denominator is having a variable. We can say that this is not a polynomial. We have to clearly distinguish an algebraic expression from polynomial. Make a note of it. The difference between algebraic expression and polynomial is that the exponents of polynomial are whole numbers. Exponent is nothing but power. Power in case of a polynomial is a whole number. In other words, it is non-negative integer. While that of algebraic expression are not. Whereas an algebraic expression can take any real value for exponents. The power of an algebraic expression it can be any real number. That is, the power can be fraction, power can be something like 1 by 2, the power can be a negative fraction, minus 3 by 4, even the power can be an irrational number. These are all real numbers. The powers are real numbers in case of algebraic expression. The powers are whole numbers in case of polynomial. Let us see the general form of a polynomial. F of x is equal to a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus so on plus an x to the power 0, where n is non-negative integer or whole number. X is the variable of the polynomial. A naught, a1, a2 till an are the constants called coefficients of polynomial f of x. Observe this last term. We know that x to the power 0 is 1. So the last term an x to the power 0 is nothing but an. This an is constant. These a2, a1, a0, these are coefficients. Here, very important thing is, since the variable is x, it is expressed as f of x, you will come across so many questions wherein we'll be having something like g of x, p of x, f of x, like that. These polynomials, they can be classified into several types. One of the way is based on degree. Other way is based on number of terms. We shall discuss in detail how they are classified based on number of terms. We know the meaning of terms. Based on number of terms, how are they classified? They are classified as monomials, which means a polynomial having one term. For example, 5x square, 7x5, 3, these are all monomials because there is only one term. Look at this example. Here I have not written any variable, or else there is a variable but the power of the variable is 0. Such type of a monomial wherein the degree is 0, it is called as constant polynomial. All the constant polynomials, they are monomials. If the polynomial has got two terms, it is called as binomial. Means it is having two terms. For example, 2x plus 3. One more example, 4x5 plus 7x square. With that, there will be two terms. If a polynomial has got three terms, then it is called as trinomial, which means it is having three terms. For example, x plus 3y plus z, 2x square minus 7x square plus z, it is having three terms. This is based on the number of terms of a polynomial. Based on degree of a polynomial, it can be divided as a linear polynomial, where the degree is a linear polynomial is ax plus b, where a is not equal to 0. If the degree is 2, it is called as quadratic polynomial. Where the degree is 2. The general form is ax square plus bx plus c, where a is non-zero. The instant it becomes 0, then it will be turned to a linear polynomial. The next category is cubic polynomial, where the degree is 3. General form is ax cube plus bx square cx plus b, where a is non-zero. The next category is biquadratic polynomial, where degree is 4. The general form is ax to the power 4 plus bx cube plus cx square plus dx plus e, where a is non-zero. What if the degree is 5? Is there a general name? No, there is no name given after the degree 4. In case if the degree is 7, then it is referred as polynomial of degree 7. If the degree is 10, then it is referred as polynomial of degree 10.